Hi, my name is Mark Smith, and I'm the host of IoT Playbook, the podcast for IoT managed service providers. Now, there are billions of IoT devices that need to be monitored, managed, and secured. And that job falls to professional IT staff or IoT managed service providers, or what I call IoTMSPs. Now, connecting a few home type devices with minor interference, you can do that with Wi Fi. But when you start scaling to hundreds of IoT devices in smart buildings, smart cities, or industrial IoT, you need to look to solutions like LoraWAN or LPWAN. Now, in this episode of IoT Playbook, I interview Albert Behr from BehrTech. BehrTech is the creator of MyThings, which uses LPWAN or low-powered WAN to connect hundreds of IoT devices through an LPWAN gateway. Now, what's different about LPWAN is that it's designed to communicate with low-powered IoT sensors across massive distances with interference that you would typically find in smart city or industrial IoT scenarios. Now, companies like Microsoft and Intel and others are partnering with BehrTech to produce solutions that work with LPWAN for real-world customers. So, just click the link below to get the IoT playbook for connecting low-powered IoT devices over long distances with lots of interference. All right, hey, this is Mark Smith from IoT Playbook, and I'm here with Albert Behr from Behr Technologies. So, welcome, Albert.
Hey, Mark. Pleasure to be here.
Yeah. So, Albert and I actually go back to our Windows, my Windows NT Mag days, where Albert actually was you can tell your story here, but with WinFax Pro and was an advertiser. So, hey, I want to thank you belatedly for helping to support Windows NT Magazine, and both of us were there on the beginning, the roots of what Windows NT took off for Microsoft and ended up becoming a phenomenon that we all know, right? And most of the people watching this make a livelihood off of what was Windows NT and now has become, servers and, even the guy that was part of that whole thing with Mark Russinovich is now the CTO of Azure. So whether you're in the cloud or whether you have on-prem servers, a lot of the work that we were part of early on is now here. I don't know about you, Albert, but for me, I'm just as excited now about this whole IoT opportunity as I was about Windows back then. So it's kind of pulled me out of mothballs to get re-excited about about IoT Playbook, but then even my own IoT managed service offering, which we'll talk a little bit about later. But so anyway, Albert, thanks for being here, and could you give us your background and an introduction?
If you and I lived in the same city, we would have been friends for 30 years because we're the same era, right? And as we go through, we'll call the case study called BehrTech. It's hauntingly similar to what Mark, you and I went through in the mid 90s with Windows 95 and 98, and now people, in the beginning of the internet. And it's just, it's one thing I've learned as an old technology guy is, old techies don't die. We just do another version update. and I just to your comment about IoT, this company called BehrTech was not a planned exercise. It really wasn't. But I would argue that after being in tech for 30 years and living in the Valley, we're in Canada, in Toronto, but getting bought, being in the Valley and living in Redmond and living in Tokyo and doing stuff around the world, I'm pretty qualified when I've seen technology. I've seen a lot of technology over the years, and so have you. And this opportunity came up, and I always described it as the Cortez moment, right? Which is I had to make a decision, right? And to burn your boats or not. I can tell you in 30 years of technology, including working for some big honking companies, and had some really cool products. WinFax was one of them. Symantec bought us for a lot of money. That's why I ended up in the Valley. I've never seen a reaction like this. And I believe in my bones that this IoT thing, whether it be industrial, commercial IoT, which we used to call enterprise, or that moves into the consumer space, ultimately, which it will, right, is that this is by far the biggest market out of all of them. Because there's only 7 billion humans on the planet, which means there's only 14 billion computers, call it. And there's only 14 billion handsets, call it, right? But there's hundreds and hundreds of billions of opportunity in terms of devices, sensors, and build, and just enabling this environment that to date has been completely analog and dumb. And what we've seen instructively over the years is that when something goes from analog to digital, think about televisions, think about radios, think about phones, right? Every time that goes from analog to digital, the market explodes and is far, far, far greater than the previous market. Right, and I think that's exactly the stage you're at right now with this market right here. So I came out of mothballs too, right? And I didn't plan on doing this either, pal. But I would not miss the greatest opportunity of my career if I didn't do this. I'd be banging my head against the wall. So that's why I'm here on this phone, on this podcast with you right now.
So let's talk about. So give me your story about how you got into this current opportunity. Explain what this opportunity is all about, and then we'll get into some specific use cases for this technology.
For 20 years, I was assisting technology companies and finding, who had cool intellectual property, and I would take them to the biggest companies in the world. And I'm an old product manager. It's all about roadmap and architecture. It's all about extending yourself off of someone's big technology. So in the case of WinFax, at Del Rena, we attached to Microsoft Office. If you bought Office, you had to buy WinFax. Mm-hmm. Real simple. And we were successful at that, and we sold for a lot of money. You want to bolt onto these big guys. Architecturally consistent, sales consistent, part of the roadmap and architecture in a way that you can both monetize. Think about the constellation of people around Azure today, or AWS. It's a great example for today's time. Anyway, so I did it for 19 years. And what happened was I had a client in Germany called Fraunhofer Institute. And Fraunhofer Institute is not a well-known name here in North America, but in Europe it is. I believe it is Europe's largest research institute. It is one of the top 5 or 10 on the planet. We would know them over here in North America as MP3. So every one of us paid these guys money. Every time you pick up your iPhone or your Android device, it made money. This the same division, right? We would also know them as SiriusXM. So in North America, it's SiriusXM. If you get a fancy schmancy new car, it's DAB audio. This is all the same guys. Deep science, very, very extraordinary science that we don't see typically in North America, says the Canadian, the guy who lived in the Valley. We don't typically see that kind of investment. So they hired me, and they had this, what I saw at the time was an early stage, astonishing technology that if anyone would have told me that in either Toronto or in the Valley or in Redmond or in DC or Austin, they would have made these performance claims. I would have called nonsense on that. I would have said, I can't say it because I promised I wouldn't swear, is that I would have called, I don't believe it, flat out, because the performance claims, and I understand this world, as you do too, Mark. You've been at this for a long, long time, right? It's just different iterations of it. And I didn't believe it, except for the fact it came from the world's largest research institutes, and they spend a tremendous amount of money building this astonishing technology. So we went and took it to our friends at Microsoft. This is 4 years ago. Senior people at Microsoft in Munich. A lot of this Industry 4.0 that we call IoT now came out of Germany, right? Industry 4.0. And took it to a friend who was a senior executive there in engineering and said, look, we think that this technology can dramatically increase Azure consumption potentially, right? Because what happens is that we have the ability to be able to light up areas in commercial industrial, in our case, that you couldn't light up before. And it was for always 2 reasons. It was either the CTO says, you're out of your mind, it's too fragile, it's not scalable, it doesn't work that well, what have you. The CTO says no. And many times, what we call the doctor no, the CFO says absolutely not. It's just way too capital intensive and it's way too operationally expensive. And typically it's the 2 of them. We said we think we have technology that could actually go and answer both solutions. Mm-hmm. So we took it to Microsoft, we tested it, and then several months later, Fraunhofer and us came to a conclusion, like it wasn't just a consulting contract anymore. We became a licensee, a global licensee of this IoT technology, where we then funded the company in Toronto, so we're a proudly Canadian company. We opened up an office in Nuremberg right away because you got to be right beside the smartest people. So startup companies from Canada typically don't open a GmbH in Germany in Nuremberg. We did, right? And we went and funded the capital ourselves through our friends here in Toronto, and we hit the accelerator. Hmm. And we believe that, using MP3 terms, that in our market, industrial commercial, we are not the Diamond Rio of the MP3 world, if people understand that. We are the Apple iPod of the MP3 world, where you have a commercial solution that can be bought through channels, through partners, in a robust, reliable, scalable business, just like enterprise in the past. And to date, we don't believe that's existed. And that's where we're focused in on ourselves and our strategic partners and our channels of sales. And so we're now growing quickly. We've been in business for 2 years now. We've put millions into this thing. And now we have our certifications, and now we're going after what we believe is an enormous market, which is completely unserved today, which is the wireless IoT market, which we believe is critical if you're going to do any kind of artificial intelligence or machine-to-machine learning.
So give me a scenario how you might use this in, because you said industrial IT, so IoT, so that would be, let's say, give me a scenario about smart building, and then I'd also like to talk about the oil and gas as well.
So I live in a big city, and lots of towers downtown, so a lot of these buildings are from the 70s, as an example. One of these is a client. I can't mention names, obviously, for confidentiality, but it's one of the 50 or 70-story towers downtown. It's a complex. It's well-known, very, very well-known tower in downtown Toronto. And, the buildings from the 70s, they have a full-time team just sitting there for water leak detection. They have a team sitting on standby 24/7 in case, not if, it's when building leaks and where it leaks from. Because the damage is so catastrophic, either from an insurance perspective or loss, business disruption or inventory, that you need to have a team that can dispatch immediately if and when they see a leak. The question is, how do they see a leak today? The answer is the tenant typically calls and says there's water pouring out of their ceiling or something like that, which is a really bad way to do it, right? And so they have multiple use cases. What they want to do is they want to have the ability of putting leak water, moisture sensors on every floor of the building, right? And have them in every corner of ingress, egress. So if there's a bathroom there, put it beside the bathroom. If it's by the sink in the sink, put it by the sink. Whatever it is, and it's got to be a sensor which can last for a long time. It's got to be battery operated. It's got to be dirt cheap. And so you're basically closing a gate is what you're doing. So any water that comes over it closes the circuit, send a signal. Right? So it happens the minute it senses any moisture whatsoever. So long before a human being sees stuff coming out, right? And you need to have the ability to be able to do this. So that's one use case that they have. And they want to put them times hundreds and thousands of these things in these buildings because it's good for the tenant, it's good for the property manager, it's good for the insurance company, it's good for everyone. That's one. Number two, air quality monitoring. Something which is now we're seeing everywhere, right? Is that we're living, especially in other parts of the world, we're lucky that you live in Denver and I live in Toronto. We have great air, right? We take it for a given, but that's not necessarily the case in other places in the world. And you're seeing, if I were in a podcast, I could grab one and show it to you, air quality monitors for inside of buildings. They want to measure the air quality of the building. They want to know oxygen. They want to know if CO, CO2, any off gases, methanes, you've mentioned in a conversation before. They want to just see it. And they want to be able to deploy those everywhere now. And each sensor cost, they're all about the same, $300-$500. Maybe a little more, maybe a little less, but not tens of thousands and not $20 yet. Industrial, commercial environments. And they have 2 or 3 or 4 or 5 use cases like this. They want to have the ability to be able to have these sensors to both heartbeat, once in a while I'm alive, everything's good, right? And then when something happens, it hits a trigger point, send an alarm. And you need to do this on a massive scale that can punch through floors of concrete and rebar. People hate carriers, no disrespect, because the data has to be on-prem, has to stay inside the building or on the campus, cannot transmit outside, no matter it's security alone, flat out, right? So they need to deal with movement. They have a whole bunch of different requirements, and our technology is uniquely suited for that. As an example, this tower. So they went up to the 49th floor, which is where this property management company owns 1,000+ buildings, really big company, right? Big towers. So they're on the 49th floor. They took an off-the-shelf Intel PC through i3, one of ours. It doesn't matter, it's a PC. Loaded our software onto it. They took a sensor and they took it down to get to the basis of the story. They got down to P2 of the basement. 51 floors of concrete and rebar. It was able to transmit signals around the building to do that. That's astonishing. No carrier, and you can put out thousands of those sensors and then plug into their existing building control management system. That's a showcase. That's a use case. There's a perfect example of a smart building in operation. Everyone wins. Tenants happy, right? Great. Good air, no damage on inventory. Insurance company loves that. Matter of fact, the insurance companies are so interested, they want to look at potentially reducing insurance fees on that because they can reduce risk, just like you have with cars today with like Progressive, where you show you're a good driver, they'll give you a discount. If you show you can put this in and you can show that you're monitoring this, it reduces their cost, everyone wins. So there's hard ROI.
So what is new then about your technology? What does it do that can't be done now, and what does it replace?
Sure. So, well, that's a multifaceted question. Let's talk about the buildings first of all. Issues when we can go to oil and gas as well. I can talk just as easily about oil and gas, but I'll just finish off because we started with the building conversation. Mm-hmm. So those air quality monitors, the ones that you buy them from today, has Wi-Fi on it and Ethernet. And you buy the box. You can buy. There's different vendors, Ethernet or Wi-Fi. And that's your choice. Do you have any idea how expensive it is to put Wi-Fi in an entire building and how fragile that is? It's one thing when we're doing a WebEx. That's one conversation. Different thing when you're putting critical infrastructure on. And it's just great. Remember, CFO, CTO. It's crazily expensive. You go around the corner and you lose a signal. You can't deal with elevators. You can't get in the basement. Or you're going to go run Ethernet, which we've heard from customers costs $1,200 a foot to trench it. $1,200 a foot just to cable it. Like, no. Like, absolutely. So if you look at the Wi-Fi, they said, look, we want to do this in a building, but we did it on one floor. We stopped with Wi-Fi on the spot. So unless we found an answer for this last mile problem, we're not doing this. We solved it. Not only did we solve it, that we could go and we could connect, but we could connect massively. So I don't need to have gateways and gateways and gateways on each floor and this one gateway, the entire building. That's astonishing to be able to do that, right? So that ability. Next ability, it has to run on batteries, right? Many of these use cases, that's the big problem with 5G, right? Huge problem. And by the way, 5G is not our competitor. We're the fingers. We touch the devices at the very end. The 5G or 4G or Ethernet or satellite, whatever it is, for us, it's the arm, it's the backhaul, right? So, but power consumption is a tremendously big problem. Think about, we'll talk about oil and gas now if you want, but on an oil pad, you may have electricity, you may not. But yet you need to monitor these things. So you need to have batteries that are going to last there for 5 years, 10 years, 15 years. If you want to put solar or wind or whatever, right? Batteries, right? And if you look at other technologies, 4G, LTE, 5G, battery CACs in 24 hours. Okay, how about having something that needs to ping every 15 minutes for 10 years because it's buried inside of concrete? Smart parking lots I just described, right? So that's what we solve.
So how would that compare to, let's say, a like a LoraWAN gateway?
So I also said I was going to be a nice boy and I wouldn't beat up on competitors. So first of all, let me start off with this LPWAN marketplace, whoever the vendors are, frankly. And it's an oligopoly. It's us, it's Lora. There's a couple of others. You have 5G who are backhauling and LTE and NB-IoT, but it's a very small audience, right? There's room for everybody. So let's make that clear. This is a huge market. If you look at Gartner's numbers or you look at Frost and Sullivan's or whoever, they're showing markets of 50, 60, 70 billion dollars just for LPWAN IoT, right? So big numbers. Lora, it's like where we excel is in scale, in production levels, manufacturing, oil and gas, mining, automotive, smart buildings, potentially defense, right? This is where we fit, where you have a military base and you want to put out tens of thousands of sensors on things, or you're in shipping and you want to deal with inventory and you want to track stuff on scale. That's where we fit, right? I think that Lora has, I won't beat up on Lora, is that they service a different market. They service a market which is in more SMBs, smaller business. You can buy a gateway, it supports 50 sensors, fantastic. It supports 100 sensors, fantastic. It really does, because sensors are commodity, right? They're all just a bunch of chips, and whether it talks in LoRa or talks my IoT, it's the same thing. It's just different ways of talking, right? It's the same chipsets, basically. So, but they have problems in scaling. They have big problems in scaling. If you go to our website at BehrTech.com, you can download a report, third-party report, where it's us against LoraWAN, and you see that they have problems. They have interference issues. As they scale up with sensors, they have to go and they have to do something called spreading factors. They have to start getting very fancy, breaking into bandwidth. They have to add another gateway, and eventually it just kind of collapses on itself. And all of our partners, all of our customers, everyone's highly educated, Mark. It's not like we're all Johnny-come-latelys. We're not, right? People have tried all these other technologies, and why they've come to us and why they appear to be buying us is because we're the ones that solve the CFO and CTO problem again. Scale is the big one. Interference immunity is a big one. Mobility, like we can deal with, dealing with objects that move up to 80 miles an hour, right? LoRa can deal with walking speed. NB-IoT, 0, right? 0 miles an hour. So it's about opening up different use cases. Note the common thread, though. Production level business is what we do.
All right, so let's talk about another scenario, oil and gas. What would that look like, and what problem does it solve for operators and things like that?
So, another good question. So let's talk about Denver. Let's talk about Colorado. Let's talk about San Joaquin Valley in California. Let's talk about the Permian Basin, right? Let's talk about in Canada, in Calgary, right? I mean, different parts of North America, same thing. You have pads down, and people are sucking oil out of the ground, right? Whether it be through fracking or otherwise, people are pulling oil and gas out of the ground, and there's thousands of holes, tens of thousands of holes, and you need to monitor these things, right? And to date, it's been really, really expensive and very difficult. And again, you have to use a carrier. Typically, you have to be in a licensed spectrum where you need to have some sort of a connection where you're paying a lot of money, CapEx, money, CFO, or forget that CFO. And you want to have the ability to be able to put a scaled environment in to basically read temperature, pressure, the what's in the holding tanks, what's the valve pressure, what's the stroke. There's a whole bunch of different parameters they need to monitor. In Colorado, we were talking before you and I got on the podcast, there's new legislation in the state of Colorado, right, where it's about methane emissions. You got to monitor this stuff, period, which means you need sensors, right? It's not about the sensors. Sensors are a smokescreen. Sensors can be done. There's thousands, there's millions of different kinds of sensors. Sensors are not the issue. The issue is communication. How do I put out, on one oil pad, I have 50 sensors. For all these different, either for regulatory purposes, case in point, state of Colorado, or they want to do it from an operational perspective. Dispatch people to something if something's not going wrong, if not going right. Dispatch them immediately. Don't wait for it to break or, God forbid, spill. Right. So how do you do that on a scale that they haven't done before, and not break the bank at the same time? We fit perfectly for that. These systems are typically run on what are known as PLCs, Mark, programmable logic controllers. We're running into a SCADA device. They're expensive. They're like $20K a pop. But if you could go and you could sensor up these things, let's say you could do it for laughs, you could do it for $4,000 or $5,000 a pop, right? And you could wire up a pad, and you do all the pads, and you're now not transmitting data once every 6 hours, or not. Now you transmit it less every 15 minutes. And more parameters. Sounds like pretty good, doesn't it? Right? That's exactly what we do. So we take a gateway. What we do, we take an Intel i3 gateway, right? We load our software-defined radio. Think of it as what we call 21st century modem, pal. It's different words, same thing. It's a modem, right? So we have that at the gateway. Boom. You put out all these sensors. They're all connected up to basically a modem on the other side. It's called a transceiver. Transceiver, fancy word for modem, right? Texas Instruments, Silicon Labs, what have you. Note, off-the-shelf nature. Vendors that have the products today. We're the software guys, right? Connect it up, put out all the sensors, send the data back to the gateway. One gateway, up to 100,000 sensors, up to a distance of 8 to 10 miles. Right, radius, diameter, 20 miles. Times a lot. And if things are moving around, that's okay, because we could track it too if you put a GPS module on it. Battery. So we love oil and gas. And we think, but we're not industry experts in any one particular area. We're a channel-based business. We have partners in every one of these areas, because it's impossible to be a smart building expert and then be a oil and gas expert the next moment and be an expert in automotive manufacturing in Mexico the next minute, right? It's impossible. So we have those partners they're bringing us these use cases. We have the same. I can give you different case studies in mining and in automotive manufacturing, and it's not us coming up with the use cases. It's the customer saying, "Look, I got this problem over here. It's costing me money." And typically now it's a manual process, and I have people that I throw against, because that's how we've always done it. And so we want to find a way, if there's a way that we can reduce our cost of operations, right? And we can increase basically availability and serviceability, that everyone wins. So that's oil and gas would be a great example of that. We're very, very, very bullish on the oil and gas marketplace.
Okay, so what would a typical offer look like? That a partner. Okay, so first of all, how does somebody partner with you? And then
Sure.
second of all, what would that partner, be packaging together to offer to their customer?
Yep.
Like,
Great question. Um, okay, so first of all, let me talk about the kind of partner we're looking for. The kind of
okay,
partner we're looking for are the guys that service those oil fields today,
okay,
right? They have the pre-existing customer relationship, and they have the pre-existing vertical domain knowledge, and they have the trust of the customer. So we can present our new cool stuff that they can credibly go and they can spec it, they can install it, they can support it. Channel-based business, no different than our old NT days, my friend. Identical. Sir, we used to call them VARs, SIs, right? SIs and VARs. They're the ones who are the customer-facing. We're second line, right? We provide them the technology. We have a complete onboarding ramping system for every one of our partners. Every one of those verticals I've described, we have customers either in North America. We're in North America and Europe right now. We're about to expand further. Right, we're dual frequency for the techies in there. I'm at 915 megahertz and I'm at 868 megahertz, and I'm also about to open more megahertz in the other parts of the world because I'm software. I can do that, right? But I have vertical partners, systems integrators, or licensing partners in those areas. What happens is they come to the website BehrTech.com, they download an application, they become one of our authorized solution providers. Standard off the shelf. Anyone who's done this before, it looks real familiar, right? We have an onboard ramping program. So we have staff here on board that train them on what is LPWAN, how do you spec it, why does this work, how do you integrate it, how do you install it. It's all about integration, Mark. It's all about integrating to existing environments to a very large degree. And so we get them on ramped. We get them on ramp. We have a marketing PR machine if they're in territory Colorado, and we get some leads that come in from Colorado, it goes to our partner based upon the vertical. Right?
mm-hmm.
So you systematize and you process it, and we're a consumption-based model. So what happens is, it's our objective to get our partners trained, and if they need to buy hardware through us, we help them with that. Right? We have stated partners already on the gateway side. We have partners on the sensor side, the transceiver side. I already mentioned Microsoft on the cloud side. We support multiple clouds. We're agnostic. We really
Mm-hmm.
are. And if they want to build their own sensor, which in many cases they do, because somebody I remember it was our biggest automotive customer. One day they were talking to us and they wanted a temperature sensor, Mark. It was very funny. And we said, okay, so what's a temperature? Right? And then one guy says, well, I want to be within a half a degree gradient. The other one says, I need to be within 5 degrees. The other one says, I need to be inside this shielded thingy because it's going in through a probe thingy. And all three wanted temperature. 3 different things, 3 completely different use cases. So what happens is if they want to build their own, or if they want to get some custom made, we have a reference design that we give the customer. Take it. It's yours. Right? And we then hook them with someone who can manufacture it. This is an FCC CE certified design. Right? They can go build it themselves with whatever fancy piece they want on it, and they're good to go for their specific need if they want. If they want off the shelf, we can help them with off the shelf. If they have existing systems, we work with them to integrate into, we have a great example up in Nevada, close to you, and it was a customer in open pit mining. They're a gold miner, one of the biggest in North America, and they had an issue with their PLC. They had a device that basically production stopped 3 days, 4 days every quarter because they had to reload this thing because they had no idea what was filled in this stupid thing. It was lime in this case, 5-story lime silo. And it stopped production cold, 4 or 5 days, 6 days, whatever, every quarter. And they didn't know it was empty till they pressed the button and nothing came out. Great. And our guys were in and out of there. There was a 20-year-old, as it turned out, Alan Bradley PLC. We were in and out, our partners with us, in and out of there in 4 hours. And for the first time, boom, they got data. Up to that point in time, they had a guy with clipboard driving around a man-made mountain every day, all day. Right? So,
Wow.
Yeah. So partners, we excel in partner management. We really do. That's because we can't possibly be these domain experts. We know that. And by the way, I'm just taking a page out of our playbook, my friend, from 1995 to 2000. It's the same thing. It really is.
Right. Yeah, exactly. All right. So if somebody wants to, like the next step, if they're interested or want to find out more about this LPWAN technology and your software and services, what would you have them do?
Go to the website.
Yeah.
Go fill out an application. But I would also encourage them, even before they even go to the website and read my propaganda, go do a Google. Go do a Google, type in wireless IoT. right? Type it, just go and play around, go and do some searches that I can't control, right? And you'll see that, and we have these third-party reports. These statements I'm making to you, even though they sound like outrageous claims, I can back up everything that I'm saying. Right? And that's why we're attracting these partners and these end users right now, right? So please come to the website, BehrTech.com, check out my profile, Albert Behr on LinkedIn, you'll see. And I think that if you're in the areas that we're talking about, this is the answer. This is the last mile for those environments. It really is. And we're very excited about that. And we think we have a very bright future. And as a proud Canadian, I'll close with this comment, which is, I'm serious. Like, Toronto's a happening place for tech. We're now apparently the number 2 tech market in North America, which is nothing astonishing. It's sort of like the Toronto Raptors winning an NBA. How does that happen? Right? We're not used to being in the limelight. But, I am hell-bent to make BehrTech, a world-class company in Toronto, Canada, out of Toronto, and not out of Silicon Valley for a change. So that's what we're not going to stop.
All right. Well, thank you so much, Albert. I appreciate it, and look forward to learning more about this, technology. So, all right,
thanks.
Yeah,
I enjoyed the chat.